Hello everyone, we are team number 26. First, we would like to explain our system architecture and design. As you can see on the graph, there are three layers in our system. The first layer is tweet harvesting. The basic rule of this layer is to harvest as much raw unprocessed tweets as we can. We use Python tweet package to harvest the tweets, including using search and streaming API. The second layer is the tweets pre-processing layer. In this layer, the main idea is to find out the tweets that include geo-coordinated data, analyzing the sentiment for those tweets, and also assign the specific SA2 area for each tweet. The third layer is web server layer. This layer provides web application servers to display the results. In this architecture, we can apply CoachDB cluster on each layer, and also each layer can be scaled horizontally. If we assign more than one machine for each layer, the ensemble script can separate the job and tell each harvest script and pre-process script that they respond to. For example, if we have 4 virtual machines to harvest the tweets, then the Ansible script can tell each node that we have 4 machines in total and which number it is. Then the script will know which area it needs to search. Although the CoachDB cluster provides a mechanism to store multi-copies of documents, we also provide a naive approach to issue that the data will not lost. We replicate the database between each layer. For example, we replicate the raw tweets database to the pre-processed cluster. In this case, even we lost the whole harvesting cluster, we can still have the raw data in pre-processed cluster, and we just need to fix and restart the cluster and rebuild the replication relationship. The system will keep going. Shown is the map illustrating every suburb in Greater Melbourne according to the statistic area level 2. With the help of QGIS and the geographic data downloaded from the Australia Bureau of Statistics, we separate the Great Melbourne into 309 different suburbs, and our analysis is based on those areas. By clicking the bottoms of the upper right corner, the dataset of one topic is broken down into each suburb with different colors. Each dataset is divided into 6 classes to some designed interval range. The suburbs belonging to the same range are colored with the same colors. Different topics give us different visualizations. Clicking the suburb in the map will show the names of the suburbs and their accurate data. For the sentiment data, we have harvested more than 3 million tweets from Twitter, and there are at least 110,000 tweets with a valid attribute of coordinates. We use this valid data to make sentiment analysis. For the others, the data are collected from the Australia Urban Research Infrastructure Network, short for ORIN, which is an official website providing large area of data. The focus is to undertake a variety of social media data analytics scenarios that tell interesting stories of life in Australian cities, and importantly, how the harvested data from Twitter can be used alongside, compared with, augmented data available within the Orange platform to improve our knowledge of life in the cities of Australia. We have chosen some datasets from the areas of education, business, health, and calculate the proportion of each area. Now let's move into the analysis part. When considering the relationship between unemployment rate and tweets, the data in broad middles will not be considered because There are only two tweets. It is easy to find that the differences among the unemployment of different suburbs are not obvious. However, the positive tweets rate in the left part of the finger is lower than that in the right part. Therefore, people in areas with low unemployment rates are happier than that with high employment. From the graph, it is easier to find that the spread of education in Melbourne is very popular. We can find that the highest percent of all Melbourne areas is only 6%, and the differences among different suburbs are not distinct. When analyzing the picture, we also need to ignore data in barometers. Through analyzing other data, it is easier to find that people in areas with high education popularity is mostly happier. This is because in this graph, Twitter in Caroline and Hampton Park, Lynbrook are the most positive, ignoring data in barometers, and the percent of education popularity in the two areas are the highest. When we look at this graph, it includes the proportion of family weekly income over $4,000 in each area. When we compare it with our sentiment result, it is not hard to find that most of the richest area, their sentiment results are more than 20% or even more than 30%. So we can say there is a relationship between family's wealth and a person's happiness. Regarding the relationship between not moving house and people's sentiments, after ignoring the potentially biased data, including Atham, Vermont South, Walter Glen, and Plenty, it could be proposed that not moving house frequently is likely to make people become happier. The possible reason might be that not moving house frequently means people have more stable life and more familiar with the neighborhood and surrounding environment.